word poly means. And poly, does anybody remember essentially what is it mean?
Poly, many?
Many, meaning many. So we're gonna talk about these diapers. You ever looked at diapers and wonder how babies can wet and just hold that liquid in? Well, poly is essentially just a long chain. And so what I have here is an example. I held this diaper up under some running water, and it went from this to this. So what do you think happened with the molecules in this?
It expands?
It expanded, exactly. It expanded. So what I want you guys to think about is, or predict how much water you think that this can hold before, that it will actually hold. And why do you think it's holding it? What reactions are going on in it that's making this hold this kind of water? So we're gonna pass out some diapers and some scissors.
That's what the kids would be like. I never thought I would need a diaper for anything.
And just cut down the seam here and removing all of the cotton fibers that are inside.
Since we don't have anything that we know about this, is there anything you want to know about it?
And don't cut your finger off?
Don't cut your finger, please. Now, if you have allergies, though, be careful because some of the fibers can cause.
I just cut through the back of the diaper.
And empty the contents into your cup.
I wrote exactly what is it. All right,
Again,
so we're going to work with
we're
that.
going to look at how much can they hold, why do you think they hold, what benefits or to the environment, and even how it impacts the environment adversely. So put all of those things.
Okay. Oh, wait. Interesting. Stuff that you're talking about?
These are the 6.
This stuff? The cotton or just the powder and stuff?
The powdered stuff. Wait, let's put the cotton in there too. Let's put it in there and just dump your powder stuff in there.
What we are going to do, rubbing alcohol. You guys are going to use these visual hypothesis. Yes.
Now, I'm going to have one of you use hot water.
Okay.
And let's see if we get a different reaction from hot water
Okay.
and cold water.
So I have to get out all this cotton stuff?
Get as much of it out as you can.
Okay.
Let's see. So the objective here is to introduce you to particles, molecules, monomers and polymers. You'll observe the diffusion of water and how it's super absorbent polymer crystals.
Okay. All right. I'm ready.
Okay, start pouring your water in.
Is this the hot water?
That's the hot water. Both of those are hot.
H2O at the top.
So what am I doing now?
Pour it in.
Okay.
Let's
Any
see.
reason behind honey at the bottom? Really thick. Okay.
Ooh. In the competition. Whoa.
How does honey move?
Is it expanding or
Yes.
is it staying the same?
It is expanding.
You also have honey at the bottom, but what makes you put rubbing alcohol at the top?
You want me to keep going?
So how many cups did you put in?
Just the
This is 1 cup.
You want me to put it in here to so you know how much it is, or you
No,
know?
just that's fine.
Okay.
Yes.
You guys are gonna do your own, but we'll have to share. So, you both had honey first at the bottom? Honey?
Wow.
First thing, we'll put it in.
Whoa.
Steal all the fun, so you guys can do it, but you only need.
I got 2 cups in there.
It's like one
See
and a
how
half
far you
cups.
can go.
Man, it's pressure.
Alright, and you both have.
Pressure.
Is it?
I see like the water like almost coming out. Ooh.
It's a little sticky, don't worry, we'll wash your hands after.
So what you're getting spilling over the top is not actual water, but
No, it's the
it's just the
expansion
expansion
of
of.
Actually, we can do this too, it'll help.
And it actually,
Oh no!
because it's kind of going down.
The water's reducing as
The water's reducing.
oh yes.
Why do you think that is?
I think it's being
Okay,
absorbed.
I have water now.
into
You have
this-
water now.
I have water now. Let's drop right there. Right there.
This- oh,
Yeah, but
I
it's like
cannot
it's actually
textually-
water.
I cannot. So essentially, you put in
Those two cups.
those
and
two
then-
cups, and this is 10 ounces. So it's probably about 8 more ounces that you were able to get in there for you. And then even
Even that
then,
still.
I mean, it's not.
Right.
So it just
I wonder if it was in a bigger cup. If it was.
if it would expand, it probably
Yeah.
would, and just continue because. I said I just held this underwater and
Yeah.
it just and I squeezed water out and was able to put more water back in, and it's continued to grow. And so, thinking in real world situation, how do you think this would benefit our environment?
We can use it to soak up stuff. I guess.
Like what? I
Um,
mean, because it absorbs what?
it looks like it absorbs water.
Water. So thinking in terms of what's going around in some of our countries, how could this be beneficial?
I guess we could use it to create like barriers from like maybe in like Louisiana or so that the levees don't.
Break.
Right.
But it's actually used in farming, forestry,
Oh,
to preserve some water.
that makes sense too. I guess if you don't have a lot of
A
water,
lot of water. You
it's
think
kind
about
of like yeah.
think about what could possibly that could benefit someone in the Sudan
Right.
where there's drought.
Right, so they wouldn't need to use a lot of water because this would soak up all
This
the
would soak
water,
up the water.
and whatever you had in it would use that water and
Use that
grow.
water, exactly. So it could be beneficial that it is used in forestry. But think of in terms of environmentally what this stuff could do adversely. Can you imagine that being flushed down the toilet?
Oh my gosh, yeah.
You know? Or
Wow.
clogging up some of our waterways. So
Right.
there's a great benefit. This could also be destructive
Right.
in many ways to our environment. But it would certainly be a great opportunity to perhaps look at solving some of our drought issues around the world.
Would you put it in water? Slip up under that oil.
So I was going to ask you all to predict how much you could put it in, but were you surprised at all at the amount of water that it could hold? She's touching.
Yeah.
Oh my God. You want a spoon?
You have
I do.
sensory
I do. I do.
Tell the kids don't eat it.
Okay, so can you describe for me what does it feel like to you, look like to you?
You've been touching on it, so what does it feel like to you?
Yeah, so as you see them,
feels like those
you can restate the hypothesis.
you know those little balls, little color things that you put in water and they expand. So I guess it's made of the
I'd
same.
like for you to put a couple of scoops in there and put some salt on it, because that salt can change the state. Okay. So let's see what happens when we put some salt.
How much?
It's like teaspoons, just sprinkle it, yeah.
And then the battery.
And see, it expanded so much that you can't get it out
Right.
of the cup. Oh, wow.
Okay.
Okay, stir it. Let's see what we get. I wonder if it's gonna turn back to its liquid state some more.
Still have some dry.
Color coordinated, see? If you can sort out your, I believe, sales.
Oh,
So it's turning back to its liquid
Yes.
state.
Straighten out the-
Wow.
look at it.
So what did the salt do to those molecules?
They disrupted,
Disrupted.
or like,
Uh-huh.
this is fantastic.
Sorry.
I feel the same way too.
I love science. I love it.
Do we have any more water?
I love it.
Yeah.
Right, you got it sorted out? So
Fantastic.
density being a
So it literally went from a solid state back to a liquid state.
It's almost like the polymer
and then
is not really a polymer anymore.
Not anymore, because that cycle has been
So did it go back to a
So we
monomer?
put-
Is that what happened?
So we put some.
What is this magical stuff? Can I have a look at that? Yeah, here.
that land
Like, what is this magical stuff?
It absorbs
It absorbs some more water. She put it in a larger container and absorbed the water.
Somebody had,
Whoever had the patent on that.
There's certain things I wish I invented. This would be one of them. Shoelaces would be the other. Maybe straws. Straws are cool invention too. You ever think about that? There's nothing left to invent. Huh. Wow. So I wonder.
Alright, and you're gonna each pick an element that you want to test the strength of. We're gonna observe what happens when we drop a round marble, big one, the same marble.
Oh God, it still has that heart.
Can I see that water?
there's no more.
Dang it, you used all the water?
I
It's
could.
okay. Don't worry about it.
Yeah,
I'm just
Well, it would be interesting to find out if it will turn back into that state after coming out of the water, or will the water still be in it? I mean, will the salt still be in it?
Right.
And won't allow. Oh, here's some
Your
water.
water?
Yeah, this is water.
Yeah.
Yeah, there you go.
Hopefully it's not alcohol.
yeah.
Rubbing alcohol.
But let's try it with alcohol. I wonder. So the salt changed the state of it
Yeah.
permanently.
It's not doing what it was doing before. That's cool. Okay.
So you tend to be
That's cool.
Worse than you.
Yeah.
Yeah, right in the middle.
So, were you surprised by anything?
This. Everything. You just want to use up all the water. No, the salt on it was actually kind of cool. What is the actual substance that it is? Do you know? Like
That's actually in the diaper. It's
Yeah.
it's called poly. It's a polysodium. It's sodium polyacrylic. So the fact that it has some sodium properties in it is amazing that when you add more salt to it, it just breaks up
Well, what do
the
you think?
chemical.
When it hit, it sinks straight to the
I'm gonna go
bottom.
look up its chemical structure when I get home.
Kind of stop.
Nah, it's cool.